right, angle similarity today. Let's get started. Remember that earlier in this chapter, we learned that in order to prove that two triangles are similar, we had to show that all three corresponding angles were congruent and that all three corresponding sides were proportional. There'll be situations in which we cannot do this, or situations in which that would be too time consuming. So, some really smart people came up with some wonderful postulates for us to use, and today we're going to talk about the angle-angle similarity postulate. This is the notation for it right here. It's a postulate in that it says we can state two triangles are similar as long as two of their corresponding angles are congruent. So this is awesome. Instead of having to show all three angles congruent and all three sides proportional, as long as we can show two angles are congruent, two corresponding angles are congruent, then we can automatically say that the triangles are similar. So let's go down here and let's do some examples. Are the two triangles similar? If so, give the similarity statement. Well, number one's a little tricky, and it's especially tricky if you can't remember what we've done in the past. If you notice here, we have these little arrows on these lines. And these little arrows mean that these two lines are parallel. They're totally parallel to each other. And if those two lines are parallel, we can kind of think about a transversal running down either side of the triangle. Now, if my transversal is LJ, then that means these two angles are congruent. And those two angles are congruent because they are a special angle called corresponding angles, right? So we can also say that LN right here is the transversal, and we can say that those two angles are congruent. Now we already have enough information here, our two angles that we were looking for, that we can go ahead and say they're similar, and we can go ahead and give the similarity statement. Now for some of you, you might be struggling a little bit, wondering what is going on the screen here. I'm going to leave my angles marked in there, but let's look at the triangle as a little triangle. I'm going to go ahead and draw it out, and as a big triangle, the great big triangle here. So LJN. Now, it doesn't matter here because we already have our two angles for angle-angle similarity, but I want to kind of point something out to you because a lot of students don't see this right away. Do you notice that they have another angle in common? Do you notice that in the small triangle, this has angle L, and in the big triangle, it also has angle L? Okay, so angle L is the same in both of them too. A lot of students don't notice that. Anyway, we already have the two angles that we need for angle-angle similarity, so I like to write the reason why. So by angle-angle similarity, triangle KLM is similar to triangle. Now K goes with J, and L goes with L, and M goes with N. And sometimes it's easier to draw those two triangles out just so you could do the similarity statement. Some of you can do it without drawing them out, and that's fine too. Whatever works for you and whatever gets you the A+. I'm going to have you all do number 2 and have that done whenever you come into class. So do number 2, have it completely done before you come into class. See if those two triangles are similar. I'm going to go ahead and move down now to these two down here. And number 3 is a special kind of problem. I call it the twisted bow tie. And the reason I call it that is because I envision this, like, not really a rectangle, but I guess a quadrilateral who someone has taken the sides and twisted it, and it's turned into this shape. And because of that, we now have a set of vertical angles right there. And vertical angles are always congruent. Now there's another thing going on in this picture, and that would be the little arrows right here. So again, these are telling us that these two sides are parallel to each other. So if these two sides are parallel to each other, we can try to view it like this. This is a transversal, right? Remember that with the transversal, we have a lot of special angles that form when it comes to parallel lines. And looking at this, I can mark this angle just like that. And the reason I can mark that is because those are alternate interior angles. So alternate interior angles are congruent. Now I'm going to go ahead and erase those lines off of there so we could look at these two triangles. Notice we have our two angles we needed, so I would say by angle similarity, triangle TPQ is similar to triangle. Well, what does T go with? R. What does P go with? S. And Q goes with Q. We're all done with that one. I'm going to have you all go ahead and complete number 4. So have number 4 completed in class. Now remember, you can pause the video right here and you can work out the problem and then unpause it and keep going with the notes. Or you can finish up all the notes and go back and do all the little problems that I asked you to do for class. It's totally up to you. And remember too, if I'm going too fast, you can pause it, you can rewind it, you can rewatch it, do whatever you need to do to get the information you need for class. All right, so let's keep going. Let's flip to the back side here of the paper. Using similar triangles, find the value of the variable. So they're telling you that these triangles are already similar. So let's go ahead and set up some proportions. Notice that we have the 90-degree mark and the 1 arc mark there. And I want you to look over here for the same thing. 90-degree mark, 1 arc mark. A lot of students don't pay attention to positioning in their triangles and they'll set the wrong things equal to each other. So our x goes with 20 and our 15 goes with 25. A lot of students mix those up. And then remember, when we have equivalent proportions like that, we can go ahead and cross multiply. So x times 25 equals 20 times 15. And we know x times 25 is 25x. And 20 times 15, I'll let you know, is 300. And it's 25 times x. So the inverse of that would be to divide both sides by 25, and if you do that, you will get 12. Okay? I'm going to have you guys do number 2 for class, so bring number 2 with you to class, have that done. It should be really similar to what we did on number 1, so hopefully that'll help. I'm going to go ahead and move it down now to 3 and 4. So let's talk about 3. There's that twisted bow tie again, and it's one of the most missed problems. Just remember, we have vertical angles right here. And then because of the parallel lines and because of our transversal, we'll have a set of alternate interior angles, which cause those to be congruent. So now we've got our angles marked, and I already see that I have angle here. And you know what? It was kind of silly of me. They told us at the beginning that all of these are similar to just set them up. But here's the thing. The reason why I like marking my angles, especially on the twisted bow tie, is because a lot of students mess up their proportions here too. Look at what we have here for 4. It goes from the 2 arc mark to the 1 arc mark. Look at your other triangle. What goes from the 2 arc mark to the 1 arc mark? It's going to be 12. So be very careful. I'll have students that set up their proportions incorrectly because they don't know how to read their angles. So 4 over 12 equals, make sure you start on the tiny triangle here first, just like you did for the 4 over 12. It's going to be equal to 7 over x. And then we're going to cross multiply. So we have 4 times x equals 12 times 7. And I'm going to tell you 12 times 7 in the calculator gives you 84. So 4x equals 84. And then that's 4 times x, and the inverse is division. So we'll divide both sides by 4, and we'll get 21. All right? So just remember the twisted bow tie. Mark your angles because it's going to make it a lot easier to see what proportions you have to write out. I'm going to let you do number 4 for tomorrow or for whenever I see you the next time. So go ahead and do 4 before you get to class again. And let's go ahead and end with 5. I'm going to go through number 5 with you. Okay, so looking at this, I see 2 triangles, but it's really unclear. Like, it's hard to see what's going on with the larger triangle. I know all of you can tell this is a 6 and this is an x. But then let's talk about the larger triangle. Look at this side right here. What's the length of that side? 6 and 4. 6 plus 4 gives us 10. Well, we added those together, so I know there's an x there, but don't be frightened. You're still going to add those together. So on the other side, we did 6 plus 4, which is 10. So on this side, we do x plus 1. Now, can we go any further with x plus 1? No, because there's a variable in there. So just leave it the way it is for a moment. Okay, now we can set up our proportions. So we can say 6 over 10 equals x times x plus 1. And then now that we have our equivalent ratios there, we're going to go ahead and cross multiply. So 6 times x plus 1 equals 10 times x. Once we do that, I see parentheses, so I'm going to distribute. So 6 times x is 6x, and 6 times 1 is 6. And I'm going to bring down my 10x. Now we want to get all our x's on one side. So what I'm going to actually do is subtract 6x from both sides, and I'll have all my x's on the right-hand side now. So we have 6 equals 4x. Okay, 4 times x, the inverse of multiplying is dividing. So if I divide, I get 6 over 4 equals x. But don't leave that as your answer. You want to reduce it. And what goes into 6 and 4? A 2. So if I reduce this, it'll be 3 over 2. And that's your answer for x. Okay, that's it. Go ahead and finish up those problems that I have marked in the video to have ready for class, and I will see you there. Until next time.